Let's look at this example of open-end credit. We've been talking about car loans and other loans where we borrow a specific amount. That's closed-end credit. We borrow that amount, we pay it off, we don't have any more credit unless we take out a new loan. Open-end credit is typically what we think of as credit cards or a charge account or a tab at a department store, that sort of thing. And so this example says Moe's Furniture Store allows his customers to have open-end credit. Abby can borrow as much as she wants, up to $10,000, pay off some of it, borrow more, pay off some of it, borrow more, borrow, as long as she doesn't go over the $10,000. So Abby decides to buy furniture for $8,000 and put it on credit. Now, first of all, has anyone ever tried to sell used furniture? Oh, it's ridiculous, isn't it? I mean, you can pay $600 for a couch, and 3 months from now put it in a yard sale and you'll be lucky to get $50 for it. So borrowing money to buy furniture which depreciates so fast is usually not a good idea. But Abby borrows this $8,000 and she decides she's going to make, what is it, $500 monthly payments till she pays it off? Yeah, she plans to pay $500 monthly payments until she pays it off. And so let's look at how that works. Moe's Furniture Store charges 18% a year. Okay, 18% a year. It actually, if you divide that by 12, you're paying 1.5% each month on your unpaid balance for that month. But that's just exactly what we do when we do compound interest, isn't it? We take that annual rate, divide it by how often you're making the payment, and that's how much you get charged each time. You get charged 1.5% each time. So interest is equal to principal times rate times time. How much is Abby borrowing? $8,000. What's her annual interest rate? 18%. And she is going to make a payment of $500 a month. So when she walks in to make her first payment, how long has she been borrowing that money? 30 days or 1 month, right? So we could either say 1/12 of a year, or we could say 30 days divided by 360, same fraction. So how much interest does she owe for the first month? Punch in 8,000 times 18% divided by 12 equals, does $120 sound right? Basically, she's paying 1.5% a month. 1% of this would be $80. Half again as much would be $40. 80 plus 40 would be $120. Does everybody get $120 for the amount of interest? 8,000 times 18% divided by 12 equals. That should be $120 interest. So she's making a monthly payment of $500. Her interest for the first month is $120. So, by the U.S. rule, we apply this $500 to that interest first, and 500 minus 120 leaves how much to go to principal? Everybody get 380? She owes $120 in interest. She pays 500. 120 of it goes to interest. We subtract 120 from 500 and get 380 that goes to principal. So after she makes that first payment, now how much does she owe on her furniture? Well, it's 8,000 minus this 380, isn't it? That's 7620. Does that look right? That's her balance, ending balance, after she makes her first payment. What we're doing here is we're doing the first 3 lines of what's called an amortization schedule, where we can see how much interest we're paying each month and how much principal we're paying each month with a fixed payment of $500. So the first month We pay 120 in interest, 380 goes to principal, now we owe 7620. This is just like those partial payment problems we did in the previous chapter, where someone walks in on day 50 and makes a payment, then day 90 and makes a payment. Only here we're walking in every 30 days and making a regular payment. All right, second month, how much is Abby borrowing? Well, she paid off some of that $8,000. She's not borrowing $8,000 anymore, is she? She's borrowing $76.20. So her interest is going to be $76.20. Oops. Write what you say. $76.20. Interest rate hasn't changed. We're still making the payment every month. Should we be paying more, less, or the same interest the second month? Less, because it's same interest, same time, but lower principal. So what does that turn out to be? $114.30. All right, so that's her interest. Subtract it from 500. She paid $5.70 less interest this time. So that means she's going to pay $5.70 more principal this time. Everybody get $385.70? 500 minus 114.30. So she pays more to principal and less to interest, and now we subtract that from her previous balance, $76.20 minus $385.70, and the survey says $7,234.30. Does that sound right? $7,234.30. And you can see how this process would go. The third month, she'd be borrowing that $72.34 amount. The fourth month, she'd be borrowing less, and eventually she'd pay off that loan, wouldn't she? And it probably wouldn't take that long, because $500 is a whole lot more than the interest for the first month. So she's going to pay that thing off pretty fast. That's pretty wise of her to make that big a payment, because 18% is a high interest rate. You don't want to stretch that thing out. How's everybody feel so far on this idea of making a payment, pay off the interest first, the rest goes to principal? Now notice a couple of things. The interest should always be getting lower, the amount to principal should always be getting higher, and these two things should always add up to the payment. Okay? So one way you can check yourself after you do one of these amortization schedules, let's do the third row. We do 72.34.30 times 18% divided by 12. We'd have even less interest. Survey says 108.51. Does that sound right? I'm cheating. I'm reading the answers out of the book. Now you punch them in and make sure you get the same thing. 391.49. We subtract this from 500. Then we subtract this from our previous balance. And what do we get, Darren? 6842.81. Survey says 6842.81. Okay. Now one way we could check ourselves, we could add these three numbers. That's the total interest we've paid in 3 months. We could add these three numbers. That's the total principal we've paid in 3 months. And then we could add those two numbers together, and it better be 3 payments worth. Okay? This sum plus that sum should equal 3 times 500. Should equal $1,500. So that's a way you can check yourself.